refine, okay, because we have some also we check if we have some vacancy inside the oxygen. Let's refine now, and we should be near the end. Okay, for this. Okay, you see now it's going much better. The second phase is accounting for, let's leave the program going a little bit more. Okay, now we are at 6.3. We save, and in principle we should check. Let's check what happened to our CO2. Well, the CO side still is negative, but the oxygen is less positive, and actually the occupancy was going down to 0.8. It's a little bit too much. If you change, actually, if you change here to, and you avoid you put neutral atom here, you will get an occupancy around 0.9. So it much depends on what kind of scattering factor you use for the cerium and the oxygen. But we are not really interested in the cerium oxide structure here. We are only interested to get a good fit, has better intensity, as much as possible a good fit, because we are fitting the line broadening and the so the instrumental broadening and the peak position, the calibration of the detector. One thing if we may improve is actually here we don't see we are plotting in square, but if we go in plot option and we plot subtracting the background here, we may see while we force replot. Okay, you don't see very well. Let's go plot option and plot also in log 10. Okay, you see our background is actually going, it's not constant in log here, but how we can quickly adjust the background. This is changing from one pattern to the other. We have two choices to do this. One is going to data file, select all the data files here, and add some background parameters. So get an additional background for each data file. But this will add a lot of parameters, not easy to fix. Or because we are very close to the good fit, we can use actually an interpolated background. Actually, the interpolated background will just interpolate the residual, will not interfere with the intensity. So it's and I prefer also to set the interpolation point manually, not so I go here, I increase the plot, then what I do, well, this is because I have a new version of macOS 10. So I go here and I say edit interpolated background point here. So what I do not want, I click with the right mouse button, I remove this point here. Okay, I remove also this point here, and actually I just prefer to put remove this one. So let's put one over here, let's put one over here, one over here, and I remove this one, I add one over here, here. I remove this one and I put a little bit more here. Actually, it will not use only one point, but a certain range of point over here. This is okay. This okay. Let's put over here and one over here. Leave this one. We put one here. Well, we can also put a little bit more than what we need. Okay, what we are missing here and here. Do we need something more? Well, actually not. In case we will add later if we need, or remove. Okay, so I close, and then I go refine again. So and let's see if we get something better. Okay, well, the background you see is not too bad. Probably we would need one more point here to get something better than this. Okay, 4. Yes, it's not moving. 5. Iteration is actually, well, actually we have quite a good fit. We actually are, the RW is 5, no background is 5.5, yes, 5.5, 5.5. So everything seems like not too bad, and here we have a little bit better fit for the background. Well, the interpolation for the background was just only putting something a little bit better. Plot option, let's say I prefer the squared, okay, and also if we plot as normally without the background, subtraction, okay, is a little bit more normal. Okay, now we can save as we have finished. And what we do actually with what we have now, we have the instrument calibrated. So I go to, first I go to parameter list and I fix all the parameter, okay, because then I go here and I want to save or export my instrument to use it later for another analysis, like for a texture analysis or using with my real sample and not. So I store here my instrument. For example, I can put in a mode. In mode there is already one database instrument containing some example, so I will just add to this one. Or you create a new file and you add to the new file. Okay, yes, and before to do this, just be sure to put a name to it so you can recognize. Just to see, if I use import, then I select instrument, MDB, and see here we have the APS, you see symmetrical loud transmission to theta synchrotron. If I choose, we just load my, we can check, should be exactly the same. If I do a computation here, nothing changed, okay? So I import exactly that instrument. Okay, that's for the first part is all. Next part we will see the texture.